What's up? What's up? It's your man, Jimmy Chan. All right, let's talk about this lab work. All right, so we're going to start on number 1. Boom, right there. So this one has the balloon, the flag, and that pin in the ground. So what you have is that you have this right triangle. All right, so you got this right triangle. Let me move it down to here so I see the right triangle. And what it says is that that this is the rope here. Let's do it this way. Here's a rope, right? Here's a flag. And here's the, what is it called? Stake. Balloon. All right. So, I almost thought that I spelled balloon wrong, but I didn't. Whew. All right. So, it says that the breeze blows the balloon so that the rope is taut and directly above the flagpole. And the flagpole, that is 20 feet from where the rope is staked down. So this is 20 here. And it wants to find the altitude if the rope is 90 feet. All right. So the only thing that has a that talks about the size of a right triangle or the relationship between the right triangles is that it is going to be the Pythagorean theorem, which states that a squared plus b squared equals c squared. So where the c is your hypotenuse, all right, and these two here are your legs, all right. So, and the hypotenuse is the largest side, which is typically opposite of the largest angle, which is going to be your right angle. So it's going to always be on the opposite side of that. So your C is going to be 90. So I'm going to have x squared plus 20 squared is equal to 90 squared. Okay. So that means I'm going to have x squared plus 400 is equal to 8100. So x squared is going to equal to 7700. All right. So with the square root method, what happens is that I got to take the square root of both sides. However, I have some things to be careful with. All right. I need to have that plus and minus. So x is going to equal to, now because I'm talking about a length, the negative will get rejected. So we're only looking at the positive side of this. So if I was to break down 7,700, it would be, actually, you know what I'm going to do? I'm going to take this right here and I'm going to put it, you know what? No. Let's not go right to left like Chinese reading. Let's go this way. So if I was to break 7,700 down, x is going to be the square root of, let me see, it'd be 77. Here, let me do it this way here. So 7,700 is going to be 77 and 100. And this is going to be 7 times 11. And this is going to be 10 times 10. 7. Oh, that definitely does not look like a 7. 11, 2 and 5, 2 and 5, right? So I'm going to have 2 times 2 times 5 times 5 times 7 times 11. So the way I deal with radicals with breaking them down into primes is that index right there is a 2, right? So because it's a 2, we're actually looking for pairs. So we're actually looking for pairs in here. There's a pair there and a pair there. Okay, and then everything else is single. So what happens? That x is going to be, so the pair of 2 comes out, the pair of 5 comes out. What's left inside? The 7 and the 11. Okay, so now I have left is 10 square root of 77. So that would be my answer for number 1. There we go. All right, on to number dos, or do. All right, so number 2 has x minus 4 squared minus 4 times x minus 4 minus 5 is equal to 0. Okay, so it says to use proper substitution. Now, you could do this as if you were to FOIL out the first part. You're welcome to do it this way. Like FOIL this out or double distribute, right? Distribute this out. And then combine like terms. And then factor and solve. So you're welcome to do that, absolutely. Okay, so that is a choice. So I'm going to take this right here. I'm going to go ahead and copy it, paste it, and shrink it, and throw it in here as a choice 2. So if you guys want to do it that way, you're welcome to do it that way, all right, as a second method. Try to find appropriate. So, oopsies. I need to do this again because I want to bring it down to the appropriate level. And just call it another method. Okay, so you're welcome to do it that way. However, appropriate substitution just means that what I want to do is replace let me do it this way. Replace this and this. So if you notice, it's the same thing, right? So whatever's in red is exactly the same thing. So what I would do is say, okay, I'm going to let, you know what, let's do this here. All right, there's another method so that this way you won't get confused. So I'm going to say let a equal to x minus 4. So if I did that, I'll have a squared minus 4 times a minus 5 is equal to 0. So now when I see that a in there, it looks like a traditional regular quadratic equation, nothing special. I can definitely do this. So from here I can factor, right? Two numbers multiplied together give you -5, yet added together to give you a -4. So it'll be a and a. So I'm going to have a -5 and a +1, because -5 times 1 is a -5. -5 plus 1 is a -4. So that works. So now I'm going to have a is equal to 5 and a is equal to -1. So one of the parts that I skipped here is the fact that after you get the factors done, what you want to do is take each factor and set it equal to 0. So that this way you have that. Okay, so there's my two answers. However, I let a equal to x minus 4, right? So this is what I did. So now I'm going to replace that a with x minus 4. So a is x minus 4, that's equal to 5. And a is equal to x minus 4, that's equal to -1. So now I have x is equal to 9 and x is equal to 3. Right? So I got add 4 to both sides. So 5 plus 4 is 9. Add 4. Add 4. So -1 plus 4 is a +3. So that means I'm going to have 3, 9, as my answer. There we go. There's my answer for number 2. Number 3. Okay, number 3. It wants me to use addition. So this is negative 3x minus 7y is equal to negative 8. And I have negative 7x minus 3y is equal to negative 32. Okay, so it wants me to use addition, which is also known as elimination. Okay, so what I want to do is decide, what do I want to eliminate, the x or the y? So let's eliminate the x. Why not? Okay, so what I have to do is, when I eliminate the x, I have to look at its coefficient, right? Oops. I got to look at its coefficient and say, okay, what can I make that equal to? I can make both of them 21, but I need one of them to be positive and one of them to be negative. So I'm going to take the top one and let's do a 7 on this one. Why do a negative 3 on this one? Okay, now it doesn't matter if I use negative 7, positive 3. No, it does not. It really doesn't matter at all. Okay, we should still come up with the same exact answer. So I decide on 7, so I get a negative 21x minus a 49y is equal to negative 56. And I get on the bottom a positive 21x plus a 9y is equal to a positive 96. Okay, so when I add these two together, that's why it's called addition, right? So when I add these two together, notice that my x goes away. So what do I have left? I have a negative 40y is equal to 40. So my y must equal to negative 1. Okay, so there is my y. Now I can certainly throw that y back into the first or second equation and get my x if I want to. However, I'm going to go ahead and do this. I'm going to go ahead and take this here, and I'm going to go ahead and show double elimination. So I'm going to come over here. Now what I'm going to do is I'm going to eliminate the y. So again, I'm going to look at the coefficient. Ooh, similar, right? So I'm going to do the kind of the same thing except backwards. So I can get 21. One has to be positive, one has to be negative. So I'm going to go ahead and multiply the top one by a positive 3 and the bottom one by a negative 7. Okay, so the top one is going to give me what? A negative 9x minus 21y is equal to negative 24. And the bottom one is going to give me a positive 49x plus a 21y is equal to a very big number. You're probably going, what is it? Let me see, 32 times 7. So it's going to give me a positive 224. All right. I know that you guys kind of get scary when it becomes bigger numbers, but no worries. So what do I get when I add these? Negative 9, positive 49. I get 40x. The y goes away because it's positive negative is equal to 200. Divide the 40, so x is equal to 5. So therefore, since anytime I do elimination, substitution, the point that I find is the point where these two lines intersect each other. So they intersect at 5, negative 1. There we go. So the part that I love about these open-ended questions and not giving you guys a choice is that you guys actually know what this means, right? I know probably while you're doing this, you did not, but now as you're going, hopefully it'll make a little more sense to you. All right, off to number 4. All right, number 4. I want you to do substitution. So I have an x minus 6y is equal to negative 26, and 3x minus 7y is equal to negative 34. Okay, so remember what I said. Anytime I do substitution, let me do this. So this wants to be a, let me just write it here. Anytime I need to do substitution, what I want to do is I want to look at the coefficients, right? To say, okay, where do I have a 1 or a negative 1? And it's obvious that's the winner right there. So I'm going to get x by itself. All right, so here, oh, that's such a beautiful arrow. I'm going to just leave it. Usually I want the program to adjust it for me. But anyways, I'm going to add the 6y over. So I'm going to have x is equal to 6y minus 26. Then I'm going to plug it in for this x right here. So I'm going to have a 3 times the 6y minus 26. Oops. Minus 7y is equal to negative 34. All right. So now I've got to distribute this 3. So I have 18y minus 26 times 3 gives me a 78 minus 7y is equal to negative 34. All right. So what do I have? I got like terms here. 18y minus 7y gives me 11y minus 78 is equal to negative 34. So when I add the 78 over, I'm going to get a 44. So y is going to equal to 4. Okay. Now, here is where the tricky part is, right? So if you trust yourself that this right here is correct, you are welcome to go ahead and plug this y right here in for, let's try that again. It's harder to do than you think. Hey, and you can just plug in for that y. So I have x is equal to 6 times 4 minus 26. So x is equal to 24 minus 26. So x is equal to negative 2. So that means, again, this is where two lines intersect each other at negative 2 comma 4. And there you go. There we go. All right, so that's number 4. On to number 5. All right, number 5. Number 5. Ooh, 3 equations, 3 unknowns. All right, so I have x plus 5y plus 2z is equal to 15. I have 4y plus 2z is equal to 12, and z is equal to negative 2. So these are the problems that were 3 equations, 3 unknowns that you really want, you know? Why? Is because this right here has already given you a result, right? So all I'm going to do is I'm going to take this z and plug it right in here, okay? So what I'm going to get now in here is that I'm going to have 4y plus 2 times negative 2 is equal to 12. So I have 4y minus 4 equals 12. 4y equals 16, so y is equal to 4. So now I got 2 answers, right? Now what I'm going to do is I'm going to take both of these and plug it into the original equation, okay? So now I'm going to take this right here. Now instead there, now I'm going to plug it into the z into here, and the y into here. Okay, so into the original. So I'm now going to have x plus 5 times the 4 plus the 2 times the negative 2 is equal to 15. So here's my 4. Here is my negative 2. So what do I have? I got x plus 20. Try again. Minus 4 is equal to 15. So why did I have minus 4 instead of plus a negative 4? It means the same thing. So typically, I ignore the addition signs. And whatever the 2 and negative 2 come out to be would be my sign. So 2 and negative 2 gives me a negative 4. So it'll be a minus 4. All right, so now I have x plus 16 is equal to 15. So x is equal to negative 1 because I got to subtract the 16 from both sides. Now, here is the thing. When you write this point, it's going to be x comma y comma z. Okay, so it's x comma y comma z. So remember, it's always in that order. Okay, so the x is negative 1, the y is 4, and the z is negative 2. So it has to be in that order as you guys write these. Okay, and there it is. I'm sweating. All right, so on to number 6. There we go. Number 6, 3 equations, 3 unknowns. A little bit more tougher. All right, so I got 5x plus 3y plus z is equal to negative 17. I have 3x minus 3y minus z is equal to negative 23. And 2x plus y plus 5z is equal to negative 26. Okay, so typically what I do is I would say, okay, so I got 3 equations, 3 unknowns. So I'm going to say that this is 1, this is 2, and this is 3. There we go. All right, so if that's the case, so typically what do? I typically take 1 and 2. And I go, okay, let me eliminate something. Well, if you notice, if I just add these two right off the bat, what happens? I'm going to get 8x equals to negative 40. Notice that the y disappears and the z disappears. Wow, this is amazing. So I got divide by 8, so x is going to equal to negative 5. Okay, so there's one of my answers. Not bad. Okay. In fact, actually, you know what? Let's do it this way. It'll be better. Style red. So you'll kind of bring that out. All right. So now out of my laziness, I'm going to go ahead and just choose 2 and 3. What the hey, right? Copy, paste. It might get me in trouble, actually. Let's see what happens, though. All right. So, yeah, that's fine. All right. So what I gotta do is so it's like, what do I do now? What do I do? Right? So let's, since I got rid of y and z, that means in this equation, I gotta get rid of y or z as well. I don't have to get rid of both. I just gotta get rid of at least one of them. Okay? Especially the fact that I have x, so I want to keep that x, especially when I do this. Okay? I know that x equals negative 5 is very different from what you've been doing, but this is actually a gift. Don't look at it as not a gift. It is a gift. Okay? So what I want to do is, let me see here. I'm gonna let's go ahead, since it's already positive negative y, let's multiply the bottom here by 3. So the top gives me a 3x minus 3y minus z equals negative 23. And the bottom is going to give me a 6x plus a 3y plus 15z is equal to, didn't we do this already? Negative 78. Okay. All right, so we got to add these two together. So I'm going to get a 9x plus 14z is equal to negative 101. All right. Just about. Yep. Okay. So there's my equation there that I'm used to. Well, since I already got the x, I'm just going to plug that x in. I'm just going to plug that x right in there. All right? So why not? So now I have 9 times that negative 5 plus 14z is equal to negative 101. Okay? So, and this negative 5. So I have here a negative 45 plus 14z is equal to negative 101. So I got to add the 45 over, and I'm going to get 14z is equal to negative 56. So z is going to equal to negative 4. Okay. So let's go ahead and highlight this and change that to blue. All right, so now I have my x and my z. So now I can just throw it into one of the original ones. It doesn't really matter which one. Let me see. I got my x and my z. Let's throw it into the second one, okay? So I'm going to go ahead and throw. So I'm going to put x equals negative 5 and z equals to negative 4 into equation, I decided 2, right? Equation 2. All right, so let's get equation 2 down here. Now, why did I do 2? No real reason. Just figure I'd do something, just make a choice, make a decision, make it right? So I got 3 times negative 5 minus 3y minus a negative 4 is equal to negative 23. So let's write those numbers in there. Negative 5 here and a negative 4 here. So I really have is negative 15 minus 3y plus 4 equals negative 23. Negative 11 minus 3y is equal to negative 23. Negative 3y. Add the 11 over, and I get a negative 12. So y is going to equal to 4. All right. So I got my x, my y, and my z. So again, I have my x, my y, and my z. So my final answer is going to be negative 5, comma 4, comma negative 4. And that again is also a point on a graph, except it's a 3-dimensional graph. Okay, so there goes that answer. And that was number 6. All right. All right, so on to number 7. Number 7. Any method you want. I have y is equal to x squared minus 3. I have x squared plus y squared equals 5. So it's probably easier to do substitution. And for me, it's this. If I throw y in here right now for the y, that means I gotta square that right side, right? So if I was to throw this in for this, that means what I would have to do is actually take this and square it. That means I got 4 of that, which that means I'm going to get like an x to the 4th minus 6x squared plus 9, right? Which is not something that we're used to, okay? So if that scares you, you're like, okay, I might be going the wrong path. That's certainly fine. You're really not, but if you feel that way, that's certainly fine. You go, okay, let me go backwards in this core maze, and let's do this. Instead of doing that, let's go ahead and get x squared by itself, right? So if I get x squared by itself, then I got to add the 3 over, so x squared is equal to y plus 3, okay? And now, the reason why I got x squared by itself is because this already has an x squared. So I'm literally just replacing that, right? So what I would have here is I'm going to have that x squared is going to be y plus 3 plus y squared is equal to 5, okay? So I see a square term, I see an equal sign, I think quadratics, that means I gotta get everything to one side. So my y squared is positive on the left side, so I'm gonna keep it on the left, plus y plus 3 is equal to 5. Bring the 5 over, y squared plus y. Subtract the 5, so I got minus 2 is equal to 0. So what I'm gonna have is y plus 2 and y minus 1. That's what I'll have. Okay. So I'm going to have, so I got y plus 2 equal to 0. I got y minus 1 equal to 0. So y is equal to negative 2 and y is equal to 1. Okay? So that's what I got. So there we go. I'm even going to do this part. I'm going to throw this up here. There we go. So from there, I'm going to go this way. I'm going to go this way. There we go. All right, just so you guys can see. So once I have that, right, what I have to do is take each one and plug it into both equations, right? So my 2 equations is these 2 right here. Nope. It's these 2 right here. Okay? So I'm going to copy this, paste this, and I'm going to try to get rid of those highlights. There we go. And so I got this one on this side, and I got this one on this side. Okay? So what I'm testing out right now is when y is equal to negative 2. Okay? There we go. All right, so that's my first thing. All right, so you know what? Actually, let's even do it this way. Boom. Let's change that style to red. So that's what I'm putting in. So now I have over here negative 2 is equal to x squared minus 3. So that means I got to add 3 over, right? So I'm going to have x squared equals to 1. If I take the square root of both sides, x is going to equal to plus and minus 1. Okay? All right, so if I put it over here on the right side, I'm going to have x squared plus negative 2 squared is equal to 5. So this is going to be a negative 2. So I will actually have an x squared plus 4 equal to 5. Subtract that 4, x squared is equal to 1. Take the square root of both sides. So anytime I take the square root, what happens? I get plus or minus 1 again. Okay? So both of these have plus and minus 1. That means when y is equal to negative 2, I actually have 2 answers. First answer is positive 1, comma, negative 2. And the other answer is negative 1, comma, negative 2. Okay, so there's my two answers right there. I got a positive one and a negative one, and it agrees with both equations. Okay, now I'm going to do exactly the same thing. So I'm going to take this right here again and copy that and paste that and throw it down here, except I'm going to do y is equal to 1. All right, so there I am. So let's plug in 1 in for y. So I got 1 is equal to x squared minus 3. Add 3 to both sides. I get x squared is equal to 4. So x is going to come out as plus and minus 2. Okay. Over here, same thing. I have x squared plus 1 squared is equal to 5. 1 squared is 1, so I have x squared plus 1 equals to 5. X squared subtract the 1 is equal to 4. So when I take the square root, I need to do the plus and minus 2. So same thing. These two right here agree. So that means I gotta take both x values. So that means here I'm gonna have when x is positive 2, y is 1. When x is negative 2, y is 1. Okay? So now if you notice, I actually have 4 answers. So my answer to this question is going to be, I might as well keep it in red, right? Ooh, it's towards the end. Okay, so let's leave it as this. So my answer is going to be this. 1, negative 2, negative 1, negative, oh, sorry. Yeah, I'm starting to write the wrong answers. Okay, so let's try this again. 1, negative 2. Negative 1, negative 2, 2, 1, and negative 2, 1. There we go. That, ladies and gentlemen, is my answer. Not the box I wanted. Ladies and gentlemen, this is my answer. Yeah, that looks better. Okay, so there you go. And that was number 7. So let's go to the next page for number 8. Boom. Ooh, that's a bad circle. There we go. There's 8. All right. Again, any method you want. So I got x minus 2y equals 3. And x squared minus xy equals 20. Ooh-wee. All right. Let's go ahead and get x by itself. So what I'm going to have here, that's a pretty good line and arrow. So x is going to equal to, I got to add the 2y over. So I get that. Okay. So I have an x right here as well, but it is that quantity squared. So I'm going to have that squared minus that times y is equal to 20. So I have to replace that x with 2y plus 3. Okay, so I have to FOIL this or double distribute. I have to distribute this. Okay, now I'm going to rewrite this a little bit. So what I actually have is 2y plus 3 times 2y plus 3 minus, now I'm not used to this being in the back, right? So I'm going to go ahead and bring it out front just like if I was really distributing, right? So 2y plus 3 is equal to 20. So, and this is where the mistake typically gets made when you don't move it. Because if you notice that we may forget about this negative sign and just throw it there and not deal with it. But now if you notice that I'm actually distributing a negative y, and that part is very important, okay? And that's why I wanted to rewrite it. So then when I FOIL the first part, I'm going to get a 4y squared plus 6y plus 6y plus 9 minus 2y squared minus 3y is equal to 20. Okay, so let's take a look at what our like terms are. I got one there with this. Let's pick a different color. I got 6y, and negative 3y, and then the 9 is by itself. So let's go back. So I'm going to have a 2y squared. 6y gives me 12y, minus 3y is going to give me a plus 9y, plus 9 is equal to 20. So 2y squared plus 9y, subtract the 20, I get negative 11 is equal to 0. Okay? So from there, I have to factor. Now, some of you guys might have to use the AC method. So when you factor this, I know that in order to get 2y squared, I need 2y and a y. Okay? To get an 11, I either have to have an 11 and a 1, which if I check my outers and my inners, my outer gives me a 22y, my inner gives me a 1y, which that combination right there won't give me a 9y. So that means that's the wrong combination. So let's try 11 and 1. So my outer gives me a 2y, my inner gives me 11y. I can get a positive 9 if this was positive and this was negative. So for this to be positive, this would have to be positive. For the outer to be negative, this would have to be negative. So 2y times negative 1 would give me negative 2y. Positive 11 times y would give me a positive 11y. So that will work. Awesome. That's what we call trial and error. So that's something that I grew up on. All right. So now I have 2y plus 11 equals 0. And y minus 1 equal to 0. So I got y equals 1. That's no big deal. On this one here, I got subtract the 11, and then I got divide by 2. So y is going to equal to negative 11 over 2. Woo, that was a lot of work, right? Okay. So with that being said, how do I want to do this here? Let's do this. Don't want to do that. What did you just highlight? Okay, so there we go. This way I'm not off the paper. And I'm just going to say that this I'm going to bring right there. There we go. All right. All right. So now I got to take these two and plug it into both of those equations up top, right? So again, I want to take these two equations again, copy it, paste it, try to get rid of these highlights. There we go. Right? So the first thing I want to work with is that y is equal to negative 11 halves. I know it's kind of dreading because you're like, I got to deal with fractions. Oh no. All right. So the good news about the fraction is that it's a y. You're like, oh, wow, what does that mean? Well, it really doesn't help with anything. It was just trying to help you out. I think with the left equation, it's pretty useful because I have x minus 2 times is equal to 3, and that's timesing negative 11 halves. So let me erase this 2 here. It's 2, meaning it's 2 over 1, right? So what happens is that the 2 actually cancels out. So what I actually have here is that x plus, because negative times negative is positive, plus 11 is equal to 3, okay? Because the 2 cancels out, so all I have left is 11. I subtract the 11, so x is going to equal to negative 8, okay? So you're like, whoa. And here's the thing. You can take this and plug into your calculator, and you will get that 11 for sure, all right? So feel free to try to do that. And then over here on the right side, is going to be a little bit different. Right side is going to be a little bit tougher. So I got x squared minus x times negative 11 halves is equal to 20. And this is why it's a little bit more difficult, because I'm going to have x squared plus 11 halves x equals 20. So this is where the difficult part is, okay? So the cool part is that I could put this as 1 over 1 and this as over 1. So that means both the far left, the x squared term, and the 20 term is missing a 2, right? Because what do they have that I don't have? Well, it's the two extreme sides, the left side, the x squared, and the 20 that's missing the 2 on the bottom. So that means I would have to multiply 2 on the top and bottom, 2 on the top and bottom. So what I'm going to actually have is a 2x squared plus 11x is equal to 40. Because since all the bottoms are the same, that means the top has to be the same. So 2 times 1 times x squared is 2x squared, 11x, and 20 times 2 is 40, okay? So, x squared and an equal sign. So that means I got to factor. So that means, well, I got a quadratic here. So I got 2x squared plus 11x minus 40 is equal to 0. Ruh-roh. So now I have 2x and an x. I gotta get 11. I gotta use 40. Ooh. Let's try a 5 and an 8. So outer gives me 16. Inner gives me 5x and 16x. In order for me to make 11, this will have to be negative. So that means this has to be negative and this has to be positive. So check it out. 2x. Check it out. 2x times 8 is equal to positive 16. Negative 5 times x gives me negative 5x. So it does work. Wow, did I get lucky or what? Or maybe I'm just smart. So anyways, I get 2x minus 5 is equal to 0. And x plus 8 is equal to 0. So I get x is equal to 5 halves. And x is equal to negative 8. The problem here is that only this that matches that. The 5 halves doesn't match up. So I can't use it. So this is only going to give me 1 point. And that 1 point is going to be when x is negative 8, y is negative 11 halves. So that's only going to give me 1 point. I'm not done yet because I still have the y equals negative 1. So, this seems like a lot of work, doesn't it? All right, so let's copy that, bring it down, paste, boom. Okay, so let me put a little border here. Okay, so now I'm going to do the y is equal to 1, right? Okay, so y equals 1. All right. All right, so there it is. If I plug into the left side, I get x minus 2 times 1 is equal to 3. So I have x minus 2 is equal to 3. Add the 2 to both sides. I get 5. Okay, over here on the right, I have x squared minus x times 1 is equal to 20. So I have x squared minus x is equal to 20. So x squared minus x plus, I got to subtract the 20, so it's going to be minus 20 is equal to 0. So my two factors are x minus 5 and x plus 4. So I got x minus 5. Oh, you know what? Let's just skip it. X equals 5 and x equals negative 4. So again, the only two that matches is the x equals 5, right? So that's the only one I can use. So when y is equal to 1, x is equal to 5. So I really have 5 comma 1, and that's all I have there as well. So in this case, I only have 2 answers, and the 2 answers are -8, -11 halves, and 5, 1. So those are the 2 intersection points of these 2 nonlinear equations. Okay. Ooh, that was 8. So 9. The worst 9 I ever wrote. Hello? There we go. There we go. Awesome. Thank you for doing that. All right, so 9. What does 9 say? Oh, the sum of the squares of 2 number. So sum of squares of 2 numbers. So if I square the 2 number and then sum them together. So I got x squared plus y squared. That's equal to 100. Okay. And then it says the sum of 2 numbers is equal to -14. Okay. Okay. So in this case, I got 2 equations, 2 unknowns. So what I'm going to do now is I'm going to take this right here, and I'm going to solve for x. So x is equal to, subtract the y, -y plus, oh, not plus, it's going to be -14 because it's still -14. This stays over there. So I'm going to replace this x with this x. Okay. All right. So what am I going to get? I'm going to get -y minus 14 squared plus y squared is equal to 100. Okay, so when I FOIL this, so that means I got FOIL or double distribute. So what I'm going to get is y squared minus, actually plus 14y plus 14y plus 196 plus y squared is equal to 100. Okay. All right, so let's combine some like terms. I get 2y squared plus 28y plus 196 is equal to 100. Then I gotta subtract that 100 over. So I have 2y squared plus 28y plus 96 is equal to 0. I have to factor. So let me bring this over here again. Ooh. Come on. Come on. Don't want to make it too small either, right? Okay. So I got a factor, right? So I have a GCF of a 2, leaving me with y squared plus 14y plus 48 is equal to 0. This is not too bad. So this is y plus 6 and y plus 8. All right. So that means I get y is equal to -6 and y is equal to -8. So there's my 2 answers, but I do have the 2 equations here. Actually, hold on. It just wants me to find the 2 numbers. It just wants me to find the 2 numbers. That means I gotta find my x and my y. Okay? So find the 2 numbers. So that means I gotta find x and y, right? All right, so if I'm only finding x and y, I don't actually have to put it all back in, right? Because if y equals -16, then x has to equal to, why did I get 16? Sorry. If y equals -6, I got too excited, and x would equal to -8. And if y was equal to -8, then x would equal to -6, right? So it doesn't matter which y it is. The bottom line is that x would be the other number. So no matter how I look at it, I'm just looking for the two numbers, right? So I don't actually have to be specifying which one is x, which one is y. I just got to find two of those numbers. So my answer is that my two numbers, so let me do it this way. The two numbers are -6 and -8. And that's all I need, okay? Because I'm literally answering the question, right? It doesn't ask me necessarily for the x, for the y. It just asks me for the two numbers, right? So it's no particular order. So this is no particular order or specification, really, okay? So there's number 9. All right, do I have enough room for 10? Let's see. We'll find out. All right, 10. Daring. Whoa, that doesn't look good. All right. Oh, boy. That looks even. Let's see. There we go. Okay, number 10. It says the difference between the squares of two numbers is 91. Okay, so if it's 91, the difference between the squares of two numbers, so x squared minus y squared is 91. Okay, and then twice the square of the second number. So we gonna decide that x is my first number and y is gonna be my second number. Okay, so if that's the case, then it says the second one says twice the square of the second number, twice the square of the second number. So if the second number is y, twice that, twice the square. Okay, so square it and then twice it. Subtracted from the square of the first number is 82. Okay, so there you go. There is my two equations. All right, so what should I do? Any method you want, what should I do? So, well, you know what? You can do elimination. Well, why not? Why not? Let's see what happens, right? So, I'm going to go ahead and multiply the top one by a +2 and just get rid of the y, okay? So if it's a +2, no, I need a -2 actually. Sorry. I actually need a -2 because when I look at the coefficient here, I got -1 and -2. I can make them both 2's, but I need one of them to be positive. So if I multiply the top one by -2, I'll get a +2. So the top is now going to be a -2x squared plus 2y squared, and that's going to equal to, I should know this, -182. Right? And the bottom is going to say x squared minus 2y squared equals 82. Oh, look at that. That's pretty. Unlike that line. Not so pretty. All right. There we go. All right. So what do I have? I'm going to have a -x squared is going to equal to -100. Right? Because the y squared goes away. So now I have x squared is equal to 100. And if I was to take the square root of both sides, x is going to equal to plus and minus 10. Okay. You know what I'm going to do? I'm going to do a double elimination. That's the way I'm feeling right now. So, copy that, paste that. So, over here on the left, I eliminated the y. So now I'm going to eliminate the x. So I'm going to multiply the bottom by -1. Okay? I'm going to multiply the bottom by -1. So the top gives me an x squared minus y squared is equal to 91. And the bottom is going to give me a negative x squared plus 2y squared is going to give me, is going to equal to a negative 82. Beautiful. So what do I have? I have, on the left side, the x squared goes away. I'm left with a y squared, and that's going to equal to a positive 9. So y is going to equal to plus or minus 3. Okay. Guess what I got to do? I'm going to have to take, actually, before I even do that, I already know what I got to do. Womp, 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 womp. I'm going to need to go to a new page anyway, so I might as well just move that right to the new page. All right, so what I got to do is now I have 4 answers. And I got to plug it into both of them. Oh boy, that seems like a headache, doesn't it? All right, so my x values is x equals 10, x equals -10, y equals 3, and y equals -3. I gotta plug all those in. Well, let's see what happens. Oh, wait a minute. I do not. Well, since I did the double elimination, that's what I got lucky with. So I gotta make all these different combinations. I actually don't have to plug them all in. I actually got lucky because I found the x and I found the y. So, because if I plug the x's in, I would get the positive 3 and -3. It was a little frustrating. Okay. How should I say this? Because I got the plus and minus 3 and I got the plus and minus 10, my answer is going to be a combination. So in other words, when x is equal to positive 10, I can get a positive 3 and a -3. And when the x is -10, I could get both the positive 3 and -3 as well. So that's what this part right here is saying, is that because no matter what, if the x is positive, I'm sorry, how would I do it this way? If the x was positive 10, I'll get positive 3 and -3. And if it was a -10, I'll get positive 3 and -3 as well. Okay, so that's the reason why both of those will work. Well, all of it will work. So therefore, this is my answer for number 10. All right. I'm sure that you guys are going to have some questions for me later. If you have anything else, let me know. See ya.